Let's just jump right into this explainer, because today we're looking at a literal microscopic war happening right under our noses. We're talking about an organism you probably haven't even heard of. It's an invisible, shape-shifting assassin living right in the dirt. And honestly, the science behind how it operates and evades our immune defenses, it's absolutely mind-blowing. To really understand this, we got to start our journey back in 1891. Picture this. A soldier in Buenos Aires, Argentina, walks into a clinic with these bizarre purple lesions all over his face and arms. The doctors are completely baffled. Enter Alejandro Posadas, a young medical student. He looks at a biopsy under a microscope and spots these weird round structures. At first, he thinks, okay, maybe it's a parasite, something like toxoplasmosis. But actually, scratch that. He had just discovered a highly pathogenic fungus.
So, that sets the stage for Part 1, the Argentine medical mystery.
You see, this wasn't just some isolated medical oddity in South America. Fast forward to the 1930s, right here in the United States, migrants from the Midwest are pouring into California's San Joaquin Valley to work the fields. They're digging into unfamiliar soil, and suddenly, boom, they start getting incredibly sick. When scientists investigated these outbreaks, they realized it was the exact same organism Posadas found decades earlier. And because of where this happened, it earned the infamous nickname valley fever.
The actual culprit? A fungus, officially named Coccidioidomycosis. And guys, this isn't your run-of-the-mill fuzzy bread mold you just toss in the trash. This is a serious pathogen. In fact, the Latin word immitis literally translates to harsh or not small, which hits the nail on the head because of how severe the disease can be. Nowadays, medical folks usually just call it cocci for short.
Which brings us to Part 2, the shape-shifting fungus. The whole secret to this thing's survival is that it's what biologists call dimorphic. Di meaning two and morphic meaning shapes. It's a master of disguise, living a total double life depending on its environment. It doesn't just, adapt a little bit, it completely changes its fundamental physical nature. Check this out. When it's in the alkaline, arid dirt of the Sonoran Desert, usually buried like 6 to 20 inches deep, it exists as these long, branching strands called mycelia. But the second it gets inside the human body, total transformation. It morphs from those long strands into rounded bodies packed full of spores. It literally becomes a completely different microscopic beast.
Okay, so we're at Part 3, invasion and multiplication. How exactly does it get into us?
Well, unlike orange mold that just floats away on a gentle breeze, Coccidioides is deep underground. So as the soil dries out in late spring and summer, the joints of its branching strands actually harden into these tough, microscopic rectangular blocks called arthrospores. They're basically armored tanks just waiting in the dirt, and they only launch into the air when that soil is aggressively disturbed, like during a huge desert windstorm or a massive construction project. What happens next is a terrifyingly meticulous biological heist. And get this, lab tests show it only takes a single inhaled spore to start the whole process. One spore. It gets into your lungs, dissolves its hardened coat, and rounds up into an endospore. Then, it builds internal walls, growing into this massive Trojan horse called a sphereole, packed with hundreds new endospores. And then, it bursts, releasing all those attackers right into your lung tissue. Each one of those can form a brand new sphereole, rapidly crowding out your airways.
And the stakes here are absolutely massive. If your immune system doesn't shut this down fast, the fungus doesn't just restrict your breathing. These endospores can hijack your bloodstream. They literally escape the lungs and travel all over the body, invading your skin, your joints, your bones, and even your brain, which can cause potentially fatal meningitis.
But oh wait, our bodies don't just surrender. That leads us to Part 4, the microscopic immune war.
Right, so to survive our defenses, the fungus uses a truly villainous tactic. Normally, these spores have a protein on their surface called cogp. It acts like a giant warning flag, screaming, "Hey, foreign invader!" But the fungus has an evolutionary trick up its sleeve. It produces an enzyme called MEP1 that literally digests its own surface proteins. It eats its own warning flags so it can turn virtually invisible and hide from our immune system's first responders. I mean, how crazy is that?
Luckily for us, our immune system has some incredible heroes. We've got a receptor called dectin-1. That's our chemical alarm system that sniffs out the fungal walls. Once the alarm sounds, our Th17 general cells call for backup, bringing in frontline attackers from the bone marrow called neutrophils to gobble up the tiny spores. And for those massive spherules that are just way too big to eat, our CD4 T helper cells step in and literally build a wall around them, trapping them in structures called granulomas.
The body also deploys two specialized teams of wandering macrophages. First up, the warriors, M1 cells. They fight the fungus hand-to-hand using incredibly destructive enzymes. But, those enzymes cause some serious collateral damage to your own tissue. So right behind them are the medics, M2 cells. Their whole job is to clean up the battlefield debris and repair the tissue. It is a perfectly coordinated military operation happening right inside your lungs.
So with all this intense fighting, you're probably wondering, who actually wins? Let's look at part 5. Who is at risk?
It turns out there's a really stark contrast in outcomes. For most healthy people, our innate immune system handles the fungus brilliantly. It just feels like a mild flu that clears up in a week. Honestly, a lot of people don't even know they had valley fever. But if there's any breakdown in your adaptive immunity, the results can be devastating. Folks with HIV or on immunosuppressive therapy are highly vulnerable. Genetics also play a mysterious role. People of African and Filipino descent are at a significantly higher risk for severe infections. Oh, and pregnant women, especially in their third trimester, are also in the high-risk category.
And guys, this is becoming a much bigger issue right now. Cases in the U.S. Southwest are rising. Why? Well, more people are moving to these arid desert areas, meaning more construction digging up that soil. Add in better diagnostic testing, plus crazy climate patterns where heavy rain makes the fungus bloom, followed by dry spells that turn them into those airborne spores. And well, these shapeshifters are finding their way into human lungs more frequently than ever before.
This brings us to the final section, and frankly, it has some chilling implications. Part 6. An unbeatable bioweapon threat. What's truly terrifying is that modern medicine still doesn't have a real cure for this. Zero. There's no vaccine. And for severe cases, antifungal drugs don't actually kill the fungus. They just hit pause on its growth, hoping your immune system can step up and finish the job. If it can't, patients are looking at years of aggressive, often toxic therapy just to keep the fungus at bay.
And because it's notoriously easy to grow in a lab, it just looks like some harmless fuzzy contaminant, and it literally only takes a single microscopic spore to infect someone, valley fever is legitimately classified as a potential bioweapons threat. Sure, it might not wipe out millions of people, but its potential to sicken massive amounts of the population and sow absolute panic is very, very real.
Which leaves us with a lingering thought to wrap up this explainer. We have no vaccine, no total cure, and a masterful biological shapeshifter living just inches below the dirt. Can we ever truly defeat this microscopic assassin? As we continue to build, expand, and dig up the desert, are we inadvertently awakening an invincible microscopic army? It's a fascinating hidden war, and one we are definitely still fighting to understand. Thanks for hanging out with me for this deep dive.